Hello. This is second video on operators and expressions session. In first video, we have seen arithmetic operators. Now we will going to see relational operators. Equality, inequality, greater than or equal to, greater than, less than or equal to, and less than is list of relational operators in MATLAB. First one is equality and inequality. Two matrix are checked for equality using equal to, which is called equality operator. Here, element by element comparison is done and output is 1, if both elements are same. Otherwise output is 0. In case of inequality, two matrix are checked for inequality using tilde and equal to, which is inequality operator. Where element by element comparison is done and output is 1, if both elements are not same, and output is 0, if they are same. Let's see in MATLAB. I am taking two simple matrix A and B. Now, y equal to A equal to B. Here you can see, second, third, sixth and seventh elements are same in both matrix, so output is 1. Alternatively, we can check equality using EQ function in MATLAB, as shown here. For inequality, y equal to A tilde equal to B. Here you can see, first, fourth, fifth and eighth elements are not same in both matrix, so output is 1. Alternatively, we can check inequality using any function in MATLAB, as shown here. For greater than operator, element by element comparison is done and output is 1, if element in first matrix is strictly greater than element in second matrix, otherwise output is 0. For greater than equal to operator, element by element comparison is done and output is 1, if element in first matrix is greater than or equal to element in second matrix, otherwise output is 0. Let's see same examples in MATLAB. Y equal to A greater than B. You can see, only first and fifth element is greater in matrix A, compared to matrix B. Alternate way to check, greater than in MATLAB, is GT function. Same is shown here. For greater than equal to, y equal to A greater than equal to B. You can see, except fourth and eighth, all other elements are greater or equal in matrix A, when compared to matrix B. Alternate way to check, greater than, equal to, in MATLAB, is GE function. Same is shown here. Let's move to, less than operator. Here again, element by element comparison is done and output is 1, if element in first matrix is strictly less than element in second matrix, otherwise, output is 0. For less than equal to operator, element by element comparison is done and output is 1, if element in first matrix is less than or equal to element in second matrix, otherwise, output is 0. Let's see same examples in MATLAB. Y equal to A less than B. You can see, only fourth and eighth element is less than in matrix A, compared to matrix B. Alternate way to check, less than in MATLAB, is LT function. Same is shown here. For less than equal to, y equal to, a, less than, equal to, b. You can see, except first and fifth, all other elements are less than or equal in matrix A, when compared to matrix B. Alternate way to check, less than, equal to, in MATLAB, is LE function. Same is shown here. That's all in relational operators in MATLAB. Let's start with logical operators. Logical operators are divided into logical operations with short-circuiting, which includes short-circuiting logical and short-circuiting logical OR, then logical logical OR, and logical NOT. First one is short-circuiting logical and short-circuiting logical OR. In list you can also see logical and logical OR. So, what is difference between short-circuiting logical operator and just logical operator? Main difference is short-circuiting logical operator will work only on scalar and not on vectors or matrix. Next difference is, with logical short-circuiting, the second operand is evaluated only when the result is not fully determined by the first operand. Due to the properties of logical and OR, the result of a logical expression is sometimes fully determined before evaluating all of the conditions. For example, in an operation, if first condition is false then all other conditions will be ignored with result as 0. In case of OR operation, if first condition is true, all other conditions will be ignored with result as 1. Let's see in MATLAB. For short-circuiting logical n. When A and B is non-zero then output is 1. If either A or B is 0 then output is 0. For short-circuiting logical OR. When A and B is 0 then output is 0. If either A or B is non-zero then output is 1. In logical n, element by element an operation is done and output is 1, if both input elements are non-zero. Otherwise output is 0. In logical OR, element by element OR operation is done and output is 1, if any one of input elements are non-zero. Output is 0, if both input elements are 0. Logical NOT returns a logical array of the same size as input. The array contains logical 1 values, where input array element is 0 and logical 0 values, where input array element is non-zero. Let's see in MATLAB, take two matrix, A and B. Y equal to, A, logical and with, B. Alternatively, we can use, AND, function for logical AND operation. as shown. Let's see logical or example. Y equal to, A, logical or with, B. Alternatively, we can use, or, function for logical or operation, as shown. Let's see example of logical not. Y equal to, A, logical not with, B. Alternatively, we can use, not, function for logical not operation, as shown. That's all in logical operators in MATLAB. Let's start with bitwise operators, and, list of bitwise operators is as below. Bitwise n. Bitwise or. Bitwise XOR. Bitwise complement. Get bit at specified position. Set bit at specific location. Shift bits specified number of places, and swap byte ordering. This is very important topic for embedded system programmer, because it is dealing with bits of byte. Let's start with bitwise n. Bit end, function returns, the bitwise n of first and second matrix. Here, you can see bit by bit details. Let's see same examples in MATLAB. Take simple matrix A and B, with data type as uint 8. We will learn about data types in next session. Now take, bitwise, and, using bit end, function. Bit end, returns bit as 1, only if both input bits are 1. Otherwise 0. So result is bit by bit, and, operation and packed into uint 8, same as input data type. Bit or, function returns, the bitwise or of first and second matrix. Here, you can see bit by bit details. Output bit is 1, if either of input bit is 1, otherwise 0. Let's see, same in MATLAB. Here, you can see, all elements in result are odd, because all LSB bits are set to 1 with, bitwise or, operation. Bit XOR, function returns, the bitwise XOR of first and second matrix. Here, you can see bit by bit details. Output bit is 1, if one input bit is 1 and other bit is 0. Output bit is 0, if both input bits are either 1 or 0. Let's see, same in MATLAB. Here, you can see, result of, bitwise XOR, operation same as presentation. Bitcmp, function returns, the bitwise complement of input matrix. Here, you can see, complemented bits. Output bit is 1, if input bit is 0 and output bit is 0, if input bit is 1. Let's see, same in MATLAB. You can see result elements with higher values because we taken input as lower values and all bits complemented. Now, this is interesting, using bitget function, we can access any bits of matrix elements. Bitget function returns the bit value at position bit in the input array. So output will always 0 or 1, but packed into same data type as input. Let's see LSB bits of matrix A, in MATLAB. Now, Let's see MSB bits of matrix A. Bit set function returns a matrix, with setting particular bit, and its value to either 1 or 0. If we didn't provide value, then bit set function set value as 1 by default, to provided bit location. Let's see here. I am only providing input matrix as A, and bit position as 4. It will set fourth bit of each element in matrix A to 1. Now, I am setting explicitly fourth bit of each element in matrix A to 1. Now, I am setting explicitly LSB bit of each element in matrix A to 0. Next bitwise operator is bit shift. In this operation, we can shift specified bits of each matrix elements to either left or right. In short, each bit shift to left is multiply by 2 and each bit shift to right is divide by 2. Here, we have to remember that for left shift, we have to give bit count as positive number, and for right shift, we have to give bit count as negative number. Here, I am shifting each element of matrix A by 2 bits to left. You can see, output is multiply by 4. Now, I am shifting each element of matrix A by 2 bits to right. You can see, output is divide by 4. Last bitwise operator is swap byte ordering. This is required where you want to change from little endian to big endian or vice versa. So in short, we can say, swap bytes function swaps the byte ordering of each element in input array from little endian to big endian or vice versa. All elements of the input array must be full, non-complex, and numeric. You can see here, I have highlighted bytes in black and red colors to see it clearly. I am taking 1 by 4 matrix of UN16 data type with elements as 0, 1, 128 and 65,535. Same shown in presentation. Now, y equal to swap bytes of matrix A. You can see, output with bytes swapped. Very important note here. For all bitwise operations, we will need inputs as either unsigned integer or signed integer matrix. Bitwise operations and not done on floating point numbers like single or double. Otherwise we will get error, inputs must have integer values. Let's see, one example. A equal to 5.5. B equal to 2.25. Y equal to bitwise and A and B. That's all for bitwise operators. In this video, we have seen relational operators, logical operators, bitwise operators. We will see special operators in MATLAB, expression and precedence in MATLAB, in next video. Thank you.